This is the audio notes for an introduction for organic chemistry in AP Chemistry. You should have worked on a reading guide a little while ago, and what we are dealing with is carbon chains for the most part. Now there's a couple of different ways you can draw a long carbon chain that's mentioned at the beginning from the reading guide. You can either show all possible bonds, or you can show only the carbon-carbon bonds. What I'm going to do is switch over to the Smart Notebook here and show you how to draw octane, which hopefully you know oct is the prefix for 8, so an 8 carbon chain. And as I mentioned on the bottom of this slide, there's 2 parts to notes today. The second part of notes is going to show you a third way to draw this, but we will get into that again later on. So if we do octane as an 8 carbon chain, you can start with 1, 2, 3, 4, 5, 6, 7, 8. It is assumed that if nothing else is coming off those carbons, hydrogen is coming off of those carbons. So now I have 3 carbons coming off with the first, 3 hydrogens coming off the first carbon, 2 hydrogens for all of the middle carbons, and then 3 on the end, because once again, carbon needs to be at the octet. Now, that took a bit of time. So there is a quicker way to draw this same thing, and if I extend the page, what I would do is I would say that I have a carbon, and you can either put the hydrogen in front or behind, but it's CH3 group, bonded to CH2. There's 1, 2, 3, 4 carbons, 5, 6, 7, and 8. Both of these are ways that the text showed and are proper ways to show an 8 carbon chain. What we need to go over today is what if there's other things on that chain? How do we name it, and how do we draw it? And again, if any time during these notes you need to pause the notes because I'm going a little too fast, please feel free to do so. However, my next slide is going over how to name these long carbon chains. And the first thing you're going to do if there's other things coming off of that carbon chain is find the longest continuous chain of carbon. If there's other things besides that continuous chain, it's called a substituent group. I just call it a subgroup. Now, we have to name that subgroup, which the text showed, like methyl groups and ethyl groups. It could be even things that aren't carbon, like a bromo group for bromine, a fluoro group for fluorine. But when we come to naming, we're going to start numbering our chains so the smallest number is on that subgroup. That does not always mean that we go left to right in our numbering of carbon chains. Now, if there's multiple subgroups on there, like a methyl group, which is a 1 carbon group, an ethyl group, which is a 2 carbon group, a bromo, bromine, alphabetical order determines how we list them. And the last rule, if you have more than one of the same group on a chain, you need to use the prefixes like di for 2 of them, tri for 3 of them, tetra for 4 of them. What you're going to find is that the naming of organic compounds almost works backwards, where you want to write the longest chain, you want to figure out what groups are coming off of it, you want to figure out the number of those groups and how many there are. As we do more examples, hopefully you'll gain a better understanding of what I mean by that. So, and I show the pages in the book, and it's going to talk about those number of carbons on a chain. What I'd like to do is talk you through these 4 bullet points, and then once again I'm going to go back to the Smart Notebook to explain what each of these are. So if it's helpful, maybe just jot down the name of these 4 examples and leave a little space for when I draw them out. That way I don't have to flip back and forth continuously during this session of notes. C6H14 is hexane. Again, hex is the prefix for 6. Ane means it's an alkane, all single bonds. However, as I mentioned in the second bullet point, you don't always have to have the carbons in a chain. They could be in a ring, a cyclo. Now, this is something that I don't believe was directly mentioned in the reading that you did for today, so that's why I wanted to bring it up. When it's a cyclo, you are connecting the first and the last carbon, which means you have to lose 2 hydrogens because you have to make a bond between each C. That's why it's C6H12 instead of 14. Once we start adding subgroups, for example, a methyl group is a CH3 group on a 6 carbon chain for this particular example. Dimethyl means there's going to be 2 methyl groups. Where are those methyl groups located? One of them is located in a carbon 2. The other one's located in a carbon 2. This easily could have been a 2,3 dimethyl or a 2,4 dimethyl or a 3,4, so on and so forth. But that gets into that backwards naming aspect. Longest chain, what type of groups coming off of it, how many of them, where are they located? And lastly, the alphabetical order part of it. If you had a 6 carbon chain with both a methyl and a fluorine coming off of it, even though the fluorine is on carbon 3, it comes first because of alphabetical order. So what I'm going to do now is switch back to Smart Notebook, and I'm going to draw each of these examples out for you. Starting with just plain old hexane. Again, I'll write the hydrogen second this time. More often it's shown in the front, but not a big deal. 2, 3, 4, 5, and 6. So this would be hexane. If instead I wanted cyclohexane, again, what I would be doing is rolling it together. Show you what I mean by that. CH2 bonded to a CH2. That would be cyclohexane. The third example I gave you was 2,2-dimethylhexane. And to save myself a little energy, I'm just going to go back to my hexane and add to it. However, if I'm going to add to any of these carbons, that means I have to take away a hydrogen. In the example 2,2-dimethylhexane, there are 2 methyl groups coming off the second carbon. That means I have to lose 2 hydrogens on that second carbon. And replace it with a methyl group and a methyl group. You don't have to actually put down the numbers, but sometimes students will just to keep track of it. 2,2-dimethylhexane. Again, some feel that that's redundant to say 2,2-dimethyl. However, in that backwards naming order, you identify how many of each group and then where each of them is. Which brings us to the last question on that page, 3-fluoryl 2-methylhexane. First thing I'm going to do is get rid of one of my methyl groups because now I only have one of them. That means I have to replace that with a hydrogen. My second carbon set, I have on my second carbon a methyl group. However, on my third carbon, I need a fluorine. Notice I got rid of one of the hydrogens. I could have drawn the fluorine on the top or the bottom. But this would be 3-fluoryl 2-methylhexane. The last topic to bring up in part 1 of the notes. So once again, when you're done with part 1, you're going to go back to working on some practice problems, I believe. And then when the time comes, you will continue the notes for part 2. is a term called isomers. You can see that in all capital letters at the bottom of this slide. An isomer is the same formula, but it has a different structure. And the example I give is C5H12. There are 3 different ways that I can draw C5H12. Therefore, there are 3 different isomers of it. So once again, if you want to write down these 3 names quick, then I'm going to switch over to Smart Notebook, and I'm going to then draw all 3 out. Pentane, 2-methylbutane, and perhaps I should have had no space in between these 2. That's something that I'm not going to be too strict about. 2,2-dimethylpropane. Easiest one would be the pentane. CH3, CH2, 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 CH3. 1, 2, 3, 4, 5 carbon chain, that is pentane. 2-methylbutane. Bute is a 4-carbon chain. Notice on my second carbon I only added 1 hydrogen because I need a methyl group on it. 2-methylbutane. Now some students might say, but wait a minute, what if I made it 3-methylbutane and put the methyl group on the carbon I just pointed to? The problem with students who would say that is that if you do that, my numbering system would then start 1, 2, 3, 4. So it would still be on the second carbon because the numbering always puts the lowest number on it. Some students would say, but why not put it on the first carbon? Well, if you put it on the first carbon, you have created a 5-carbon continuous chain. All you did was draw pentane in a slightly different manner. However, there is one more isomer of this, and that would be the 2,2-dimethylpropane. Doesn't matter which way you number this. I can number it 1, 2, 3. I can number it 1, 2, 3. No matter how you number it, it is 2,2-dimethylpropane. So once again, this is the point that we can now pause the notes. And I believe on my subnotes it says give students 10 to 15 minutes to do the front page of the organic naming and drawing practice. After that time has passed, start up notes again as we'll be moving on to the next topic, the 3rd way to draw these organic molecules. We are back with the second half of notes, and that is starting with what's called line angle drawings. And actually our textbook does show this a little bit at the beginning of the organic chapter. I just did not include it on the reading guide, so you can always look back earlier in the textbook and can show this to you. Since organic chemistry encompasses so many molecules, and quite frankly a lot of them are large, a way has been developed to make it quicker to draw these things. So what we're going to go over is both that quicker way called line angle drawings, but then also we're going to have a little fun with it. So we're no longer going to draw carbons or hydrogens. Instead, it's going to look early on like we're drawing zigzag lines. And what those zigzags represent is at the end of each line and at each angle is a carbon. Hydrogens are assumed to be there to get it to the octet if nothing else is bonded to it. So what I'm going to do is go over 2 examples with you right now and then give you a chance to try to work on more problems that you picked up on the way in. So, if I wanted you to draw out 2,2,3,3 tetramethylbutane, you always start in the back end with the butane. So what I showed in my first picture is butane. At the end of this line is a carbon with 3 hydrogens assumed to be coming off of it. At this angle is a carbon, and it would only have 2 hydrogens, I suppose. A carbon and a carbon. By doing this zigzag, I've drawn a 4-carbon chain, which is a butane. I need now 4 methyl groups. Where are those methyl groups? 2 of them are on the second carbon, 2 of them are on the third. I drew 2 more points here and here. So again, this is 2,2,3,3 tetramethyl butane. My last slide. Typically, when you draw out line angle, you do not have to actually number it. I simply put the numbers on there to help you in trying to name it. If you need help, let's go back to this right here. 1, 2, 3, 4 carbons and a methyl group off the second carbon. This is the exact same drawing as this. This is 2-methylbutane. So what your goal is today is to learn a little bit about how to name these organic molecules, these single bonded carbon chains, because next class, when I'm back, we're going to do double bonds and we're going to do triple bonds. So what I have on my notes then for you guys to do is you can work on the back side of the organic naming and drawing practice. Remember, you can always check my answer key if that helps out. But then, as you'll notice on the back side of that problem, how I kind of spelled things out, I want you guys to practice that as well. And my sub will read the directions so you know what to do for that to kind of create your own problem and have someone else try to solve it. But that wraps up the notes on organic introduction, naming of alkanes.